Hi, in IIITMK we have selected 28 projects for Cohort 2 and all of these teams are from different colleges across Kerala working on different domains like security, environment, agriculture, clean tech, etc.
FightFire is a wildfire predicting tool that will allow the local firefighting authority to respond quickly to the wildfire. In current scenario, there is only a wildfire monitoring and prevention in nature, but I create a prediction device. The wildfire are mainly due to the increasing atmospheric temperature and decreasing soil moisture. So I consider those two parameters and create a node. And I have a node and this is a gateway. This consists of a LoRa network and this communicates to the server. Inside the server, there is a machine learning algorithm to predict the wildfire.
Our project name is Luminos. It's an innovative ironbox. As we know, conventional ironbox use a lot of energy. I think about 1000 watts. So we are planning to reduce the energy consumption of conventional ironbox, but it's very difficult to reduce the energy consumption while it is using heat coil as that heat source. So we decided to change the heat source from heat coil to something else. So we came to know about halogen lamp. Halogen lamp is only about 20% efficient. That means 80% of it is lost. That 80% is lost in the form of heat. So we decided to put that halogen lamp as a heat source.
Our idea is to implement visual SLAM algorithm. Visual SLAM is the technology in which we use camera feed, that is camera images, in order to for building a concurrent map and to navigate. This technology can be applied in various fields. We can use this technology for using aerial mapping as well as aerial surveillance. This is very useful for farmers. We can actually find out how much hectares of land is being cultivated, which part need more irrigation, how the plants are behaving to the climate change, etc. So this is a very useful thing.
My project is based on a smart water tank. So the basic concept of my project is to check the level of water and pump the water from a reservoir to the tank. I am using probes to detect the level of water, that is passing the current through to a circuit shows whether there is water in the circuit or not. So when the water we know that the water conducts electricity. When current is passed through it, if there is water, the electricity passes through it and we know whether the water is there or not.
Aroha is a convertible bed in which a part of the bed can be converted into a wheelchair as well as a stretcher. So if a patient is lying in our bed, the center part will be a moving part. So with the push of a button, the center part will be converted into a wheelchair or a stretcher as required. So with that, we can reduce the amount of human effort required and also there will be no problem with the comfort of the patient.
We are working on an automated hydroponic system for the people, those who live in flat apartment and those who don't have land or backyard to cultivate their daily required vegetables. Our system will provide fresh and poison-free vegetables.
Our product is the automatic cleaning of the ceiling fan, and we got this problem from the survey conducted by us. And we are putting this cleaner on the base of the fan. Base of the product is clamped on the center of the fan, and then the shaft is rotating around and cleaning the entire leaves.
My project is Smart Bin. So I have done a small prototype on Cohort 1, and in this Cohort 2 I have hosted the project in the college intranet. So this project is lively running on the IoT lab and also in thingQbator. So what actually my project does is that the waste level of each smart bin will be calculated and is transferred to the server, and based on that the percentage of each smart bin will be shown in the web page, so that the waste collector can easily identify which all waste bins are filled.
We have made a product and that is added to a current CCTV camera system. It can make it super smart by giving the power to stop burglary, by detecting and analyzing the person at the doorstep, by triggering a loud alarm at that same instant, with that waking up the residents of the house and driving away the burglars.
Happy to see that the second batch of thingQbator cohort also has graduated. This time we had a larger batch. We have 86 students, and the success rate is quite high. That we have out of the 28 teams, 13 of them could come out with viable products. One of the major difference of the thingQbator at IIITMK is that it plays a role of a regional hub for pre-incubation of ideas in electronic hardware and newer technologies, because as a state, IIITMK play a very important role to create the ecosystem in the electronic hardware space. The Maker Village at Cochin, as well as in Trivandrum, and the hardware accelerator being set up with the support of Brink, actually make sure that the quality products coming out of the thingQbator actually get into that pipeline and convert themselves into the global product in no time.
It is a great delight and an honor to be part of Cisco's thingQbator at IIIT campus. We have been having a wonderful learning experience so far, with more than 200 students associating with us in the last two cohorts. We had about 28 teams in this last cohort, and more than half of them are from other colleges of the state, which clearly indicates the kind of acceptance and support the thingQbator concept has received in the state. I'm really thankful to the faculty members, management and the professors for their interest. Another significant point to note is that many of the innovative and creative ideas that has come up in this cohort could be linked to the market. We are extremely thankful to Cisco and NASCOM for their extended support. We look forward to nurturing more innovative and creative ideas in the upcoming cohorts, addressing more societal problems. Thank you.